lesson for today is on empirical and molecular formulas. Our objectives are for you to know the definitions of empirical and molecular formulas, be able to convert between the two types of formulas, use percent composition data to calculate the empirical formula for a substance, and then use the empirical formula and molar mass data to solve for the molecular formula. Let's begin by looking at the empirical formula. This is the formula that gives the lowest whole number ratio of the atoms of the elements in a compound. I've given you a couple of examples. The first example is water. We see that we have a 2-to-1 ratio. Anytime you have a 2-to-1 ratio, that is the lowest as it possibly can be, so that is going to be your empirical formula. Lithium fluoride has a 1-to-1 ratio. Again, that cannot be simplified any further, so it is the empirical formula. Now, in order to calculate the empirical formula, if you are given the percent composition, there are 4 steps. I've summarized those 4 steps into a poem. The poem says, percent to mass, mass to mole, divide by small, multiply till whole. Let's take a look at an example. A compound contains 72.2% magnesium and 27.8% nitrogen. What is the empirical formula of the compound? Okay, since we are given percent composition and asked for the empirical formula, we know we're going to use the 4 steps of the poem. Those include percent to mass, mass to mole, divide by small, and finally multiply to whole. The first step says percent to mass. All we're going to do for that is change the percent sign to grams. So instead of having 72.2% magnesium, we're going to have 72.2 grams of magnesium. Now we'll do the same thing with the nitrogen. So we have 27.8 grams of nitrogen. That takes care of the first step. The second step says mass to mole. We know that to change grams to moles, we're going to use the molar mass. So we look up the molar mass of magnesium on the periodic table. We see that it is 24.30 grams per mole. Nitrogen is 14 grams per mole. Okay, so when we do the math, 72.2 divided by 24.30, we get 2.97 moles of magnesium. 27.8 divided by 14 is 1.99 moles of magnesium. Okay, the next thing says to divide by small. So we're going to look at our numbers and determine which one is the smallest. Obviously, that is 1.99. So we're going to divide both of these by that 1.99. When we do that, we get 1 for the nitrogen and 1.5 for the magnesium. In this case, we do have a number that is not a whole number, the 1.5 for magnesium. So we're going to have to find a multiplier. Now there's a couple things that you need to remember when you are talking about multipliers. If your number is 0.1 or lower, you can just round down. If your number is 0.9 or higher, you can just round up. Any other number, you're going to have to find a multiplier, and those are going to be either 2, 3, 4, or 5. In this case, since we have 1.5, which is a half, we're going to multiply it by 2, which gives us the whole number of 3. Just like in every other math class you've ever taken, what you do to one, you have to do to the other. So we'll multiply the other one by 2 to give us 2. This has now given us our subscripts for our formula. So my final empirical formula is Mg3N2. Okay, pause the video at this time and practice this question. The answer to example 2 is C4H6O. Let's take a look at how it's done. A compound is analyzed and found to contain 68.54% carbon, 8.63% hydrogen, and 22.83% oxygen. What is the empirical formula? Again, we're given percentages and asked for the empirical formula, so we know we're going to use our poem. I'll write it again up here for our reference. Percent to mass, mass to mole, divide by small, and multiply to whole. Okay, so again, we start with percent to mass, which is just changing our percent sign to grams. So we have 68.54 grams of carbon, 8.63 grams of hydrogen, and 22.83 grams of oxygen. Step 2 is mass to mole. So we're going to divide those by their molar masses. Carbon is 12. Hydrogen is 1, and oxygen is 16. So 68.54 divided by 12 is 5.71 moles of carbon. 8.63 divided by 1 is 8.63 moles of hydrogen, and 22.83 divided by 16 is 1.43 moles of oxygen. Step 3 is divide by small. We see that the smallest number is 1.43, so we'll divide all 3 by that number. That's going to give us a 1 for the oxygen. 5.71 divided by 1.43 is 3.99, which we can round to 4. And 8.63 divided by 1.43 is 6.0, which we can round to 6. So in this case, we have all whole numbers, therefore we do not need to use a multiplier. So my final empirical formula is C4H6O1. Continue watching the next video for molecular formulas.